Hey folks, let's go through this today. So, volume is different than surface area. It's related. We're dealing with 3D shapes, but basically what it is it's how much stuff you can fit inside of a shape. Okay, so if this was a box, and you want to know how much sand or liquid or something like that you could fit inside, that is the what's said to be the volume of this shape. Volume calculations are very straightforward. Okay, their surface area, you had to find the area of each of the sides and add them up, and top, bottom, left, right, front, back. For volume, you don't have to do that. Okay, it's very straightforward what you need to do. I'm just going to draw in a little bit here so you can kind of see the part underneath. Okay, so basically all you have to do for volume is find the area of the base. Okay, so that's kind of the part that the shape is sitting on. Okay, usually. So this is a rectangle. Okay, the base, the bottom of this shape is a rectangle, and the formula is the area of the base times the height of the shape. Okay, so basically we've got this rectangle, which is 8 times 5, and then I'm going to multiply it by the height, which is 3. Okay, so that's all we do. That's it. So 8 times 5 is 40 times 3 is 120. Now, because we're talking about volume, volume is it's in 3 dimensions. Okay, so for area we had units like meters squared, but for volume we will have meters cubed. Okay, so this 3 is new. So in this case, the volume of this box would be 120 centimeters cubed. Okay. All right, let's look at the one, this triangular prism here. Okay. So for volume, it's the area of the base times the height. Okay. So this is a triangular prism. So its base is going to be this triangle on the bottom here. Okay, so we're going to have to find that first. So we know if we're finding the area of a triangle, okay, this bottom blue base here is the same as this. So to find the area of this triangle, okay, because this one's the same, it's the horizontal by the vertical divided by 2, because it's a triangle. So we're going to have 50 times 48 and then divided by 2. Okay, so the area of the base is 50 times 48 divided by 2, which gives us 1200. And now we're going to times it by the height, which is 80. So times 80, and the volume of this triangular prism is 96,000 centimeters cubed. Okay, so this one was B, and this one is D. Okay, let's take a look at the next page. Okay, so we've got another triangular prism here. Okay, and its base is the triangle. Okay, so what we're going to do is we have to find the area of that triangle. Now, I put a hint here, you need Pythagorean theorem. Why? Well, this is the horizontal, say, by the other dimension, the vertical we can call it. We don't have this measurement. Okay, we do have this one, okay, which is 17, so we know this back side here from this corner to here is 17, but that's not the completely horizontal vertical one that we want. Okay, we're always going to deal with the one that meets at 90 degrees. So this 17 is actually a decoy. Okay, what we need to do is find this side length instead. Okay, but we can find that because if we know that this is 8 and this is 17, this is the hypotenuse. So we can do a squared, b squared, c squared to find this, I'll color it green here. We're trying to find this green side because it will match up with this side. So Pythagorean theorem, we have the hypotenuse, and we're trying to find the short side. So it's going to be 17 squared minus 8 squared, and that gives us 225, and the square root of 225 is 15. Okay, so that means that this side down here is 15 centimeters. Okay, now that we have that, we're going to find the area of the base here and times it by the height of the shape. So this is a triangle with dimensions 8 and 15. So we're going to multiply those together and divide by 2. So we're going to have 15 times 8 divided by 2. And then I'm going to multiply that by the height of the shape, which is 6. So when we do this, we get 360 centimeters cubed. So the answer is B. Okay, the cylinders at the bottom here. So the cylinders, you've probably noticed in a rectangular prism, we find the area of the base, which is a rectangle, and times it by the height. For triangular prisms, we find the area of the triangle and times it by the height of the shape. So similarly with cylinders, we're going to find the area of the circle. Okay, we're going to find this, and then we're going to times it by, in this case, I guess, the length of the cylinder. Okay, so this one's going to be 14 is what we're going to multiply it by. But first we're going to find the area of the circle. So area of a circle is pi times r times r. So 3.14 times the radius, which is 7. Okay, they gave us the diameter all the way across. We only want half, so 7 and 7. And then we're going to times that by 14. Okay, so times by 14, which is this one. Okay, and once we do that, now the rounding was a little weird on this question, so let's see what we get. So we get 154.04 yards, cubic yards. And the only one that's close to that is B, so the answer is B. Okay, and the one down here is very similar. We're going to multiply, we're going to find the area of the base, which is a circle. Okay, so that's going to give us pi 3.14 times the radius, so times 11 times 11. And then I'm going to multiply that by the height, in this case 16. And when we do that, we get 6,079.04 feet cubed, so our answer is C. And that's how you find volume, okay? Volume is a lot easier than surface area because there's less organization. you simply find the area of the base of the shape, which we know how to do. For rectangles, it's length times width, or horizontal by vertical. For triangular prisms, it's horizontal times vertical divided by 2. And for cylinders, it's pi times the radius times the radius. Once you find that, you simply multiply it by the height or the length of the shape. So here we multiplied it by 14. Here we multiplied it by, let me circle it so it's green for you guys, we multiplied it by 6. Okay, and down here we multiplied it by 16. That's all you have to do. Okay, if you have any questions, don't hesitate to email me, and hope we're doing okay. All right, take care.